Okay, this is the Math 1113 Zoom meeting for April 30th, last Zoom meeting of the semester. We'll start off with a few problems from 7.5 and then we'll go over the final exam review. Why don't we start with ones on, one like number 9, page 610. A cosine of 2 theta, 3 sine theta minus 1. All right. Now remember, there were 3 different versions of cosine of 2 theta. We're going to want the version that we can match with a sine here. If you remember, that would be 1 minus twice sine squared theta is equal to 3 sine theta minus 1. Collect all the pieces over here, I'll have negative 2 sine squared minus 3 sine. And I'll have a add 1, and add 2. This piece, switch over, that'll turn negative. Add 1 plus 1, I'll get 2. Let me divide through 2 sine squared theta then. Add 3 sine theta minus 2 equals 0. Let's see if we can succeed in factoring this. Go 2 sine theta, How about plus 2 and minus 1? 2 sine minus, no, that's going to give you minus 2 plus 2, which is 0 in the middle. So how about 2 sine theta, and put the plus 2 over here, sine theta plus 2 minus 1 there. How about that? 2 sine squared plus 4 minus 1 is positive 3. Negative 1 is 2 is your negative 2. There it is. So this is going to give us a sine theta 1/2. Because we're sending each piece to 0, so you add 1, divide by 2. That's going to give you a pi over 6 and a 5 pi over 6. And I could add the plus 2 pi k on them if I want. Here I'll have sine theta is a negative 2. That's greater than 1. At least, the absolute value is greater than 1, and therefore, there's no solution. All right, why don't we try one like 13? Sine of theta minus 1 equals a cosine. Now, if these are sine squareds and cosine squared, I could easily convert one to the other, but they're not. So really the trick here let me think. First trick I was thinking of was trying to divide by the cosine, make a tangent, get it down to a single function. Otherwise, I got to go like cosine is the square root of 1 minus sine squared, and then you got to square. It's that complicated. If I divide through by cosine, I was thinking I could divide through by cosine. I got to divide everything by cosine. This may not get me anywhere. There's a tangent minus a secant equals 1. Don't really get me anywhere. Remember, a cosine squared is 1, well, not a square root, is 1 minus a sine squared. So a cosine will take to be a square root of 1 minus sine squared. Something I think to do. So if I plug in have sine theta minus 1 equals the square root of 1 minus. I've at least got it all in terms of a sine. If I square, I got to go sine theta all squared equals 1 minus sine theta. You cannot just square this and square this. It's got to be squared as a group. So then this FOILs out as a sine squared minus sine is minus 2 sine. Add 1 equals 1 minus sine squared. When I squared here, the root went away. Well, the ones are going to cancel. If I bring the sine, I'll have 2 sine squared minus 2 sine. 0, because the ones will cancel. Take out a 2 sine. That'll leave a sine minus 1. All right, maybe we're getting somewhere. So first case, a sine theta is equal to 0. You have 0 pi and 2 pi. And if you've got sine theta equal 1, then you just have pi over 2. I'm just writing down the front answers, not adding on the 2 pi k. Okay, so yeah, sometimes you try different identities and it really doesn't get you anywhere. So back up here, this trying to divide through by cosine didn't really buy me much. All right, how about one like 19? And then maybe we'll try one toward the end. And then we'll get on the final exam review. Twice cosine of 2 theta, add 1 equals 0. And I'm really just going to concentrate on part B. The 6 solutions are all solutions in 0, 2 pi. So can you tell you're going to get cosine of 2 theta is a negative 1/2. All right, that's where I come over here to the side. That's where you're going to get your x-coordinate being negative 1/2, it'll be this way. That's where you're going to get negative 1/2, and then down here, negative, well, the origin is supposed to be like the origin, negative 1/2 in there, at least for the x-coordinate on both of these, which means you're at pi over 3 equivalent, or reference, which means you're at 2 pi over 3, and you are at 4 pi over 3. Okay, theta would be 2 pi over 3 and 4 pi over 3 if you were solving cosine theta equals negative 1/2, but we're solving cosine 2 theta equals negative 1/2. So that means, first cut at it, 2 theta will equal 2 pi over 3. Instead of just theta equal 2 pi over 3, the argument is 2 theta, which means theta is 2 pi over 6, which is just pi over 3. Now, in effect, you're dividing by 2, pi over 3. All right, secondly, 2 theta then will equal 4 pi over 3. And if you divide by 2, your theta will equal 2 pi over 3. So you're going to get 4 times as many solutions inside 0 to 2 pi. So if I go the next cut at it, 2 theta will be 2 pi over 3, add 2 pi, that's 6 pi over 3. That's 2 theta equal 8 pi over 3. 6 pi over 3, add 2 pi over 3 is 8 pi over 3. Divide by 2, I'm at 4 pi over 3. All right, yeah, pi over 3 bigger than pi, so I think we got one more cut at it. 2 theta would equal 4 pi over 3, 2 pi, that'd be 6 pi over 3. So you're at 10 pi over 3. Theta would then be 5 pi over 3. And now you're as close as you're going to get to 2 pi. Next one would be over. Answers, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And your basic answers to part A would just be these two adding on to pi k. All right, why don't we try 33, the last one, and then we'll hit the final exam review. Okay, problem 33, page 611. We will hit 2, and it's 2 sine theta, tan theta, minus tan equals 1 minus 2 sine. Let's see if we can collect every piece over. 2 sine tan minus tan, add 2 sine minus 1. Adding that over, and I'm subtracting 1 over. I try grouping. Let's pull tan theta out, leaving 2 minus 1 plus, now the group here is 2 sine minus 1. You can see it's so easy, it's hard. It's absolutely identical, so it's like having a 1 there, which you don't technically have to show, but you do on the next line when I factor out 2 sine theta. And I'll be left with tan theta plus 1. If you don't stick a 1 there, then you're an amateur. It's hard to get the factoring right. There's your 2 sine theta times tan theta. 2 sine theta times 1 is right there. Minus tan theta is right there. And minus 1 is right there. So yeah, it's a good factoring. Sine theta here is a half. That's going to give you pi over 6 and 5 pi over 6. Tan theta here, negative 1, and that's going to give you the pi over 4 equivalent in the second quadrant. That's going to give you 3 pi over 4 and 7 pi over 4. Second quadrant, fourth quadrant. Second quadrant, fourth quadrant with pi over 4 equivalents. All right, well, that's pretty good examples out of 10, 7, 5 again. Let's go ahead and charge into the final exam review. We'll just walk our way down through it, see if anybody has any questions about it. I don't know if I need to hold it up a little closer. All right, you're given that cosecant of theta is 2, and theta is in quadrant 2. And they want you to find all 6. This is the final exam, so it's covering comprehensive over the whole semester. So given quadrant 2 theta, that would be this way. Your cosecant's 2, so your sine is 1/2. So there's your 1, opposite over hypotenuse, 1/2. Square root of 2 is 4, minus 1 is 3. Square root of would be this leg, but it's negative because it's quadrant 2. So that gives you a sine theta of 1/2. Your cosecant theta is 2. That's given. Cosine would be negative root 3 over 2. Secant would be the flip of that. Tangent would be negative 1 over root 3. And cotangent would be flip that up. You don't have to write it over 1. Put a line under it. I guess it doesn't matter. How about a sine of 11 pi over 6? Well, I could draw the diagram. But yeah, your pi over 6 short of 2 pi. Negative a half. It's pi over 6, your y sine's negative a half. In the fourth quadrant's negative, but it's a half. All right, well, problem 3, at 45 degrees, your legs are equal, so x is 20. We could do the algebra and show you. At 30 degrees, your vertical side's half your hypotenuse. Should have put an angle symbol in there. X is 15, vertical side's half your hypotenuse. At 45, your legs are equal. But, you know, we could write out the equations and the numbers if you needed it. Here's a triangle. We want to take the cotangent. The tangent of theta would be opposite over adjacent, 15 over 8. So your cotangent's to flip, 8 over 15. Number 5, you're given that a cotangent's 1/4 and your sine, which means your y-coordinate is greater than 0 positive. I want you to find sine of 2 theta. So here's the triangle for it. Cotangent would be 1 over 4. 4 squared is 16, 1 squared is 1, 16 plus 1 is 17 square root. And your sine of 2 theta from your identity, double angle identity, is 2 sine cosine. So your sine is 4 over root 17 and your cosine is 1 over root 17. 2 times 4 is 8 on top. Root 17 is root 17 is 17. 8 over 17. Notice it's less than 1 as it should be. Doubling the angle means you're just swinging further around. Sines, cosines, tan, doesn't matter what the argument is, are always less than 1. All right. Given a sine t is negative 1/4. Your secant, which means you're 1 over your x-coordinate, but still less than 0. That means you're going to be second or third quadrants. I'm going to use version 1 of cosine 2t. So here's your triangle. If your sine is opposite over hypotenuse, then this has got to be 16 minus 1. Negative 1 squared is 1. 16 minus 1 is 15, and it's going to be negative root 15. So cosine is negative root 15 over 4 squared. Sine is negative 1/4 squared. So you're looking at 15 over 16 minus 1 over 16 is 14 over 16 or 7/8. Again, still less than 1. All right. Verify that a cosine over a secant plus a sine over a cosecant comes out 1. If you sub in a secant as 1 over cosine, then it's going to flip around to cosine squared. And a cosecant is subbed in as 1 over sine. Flips around to sine squared, and a cosine squared plus a sine squared does indeed equal 1. All right. Given these sum identities, so there's signs of sum and difference of angle identities, section 7.1. Verify this, and so it's a matter of plugging and chugging. You go sine first, cosine second, minus cosine first, sine second. Over here, sine first, cosine second, plus cosine first, sine second. Sine of pi over 2 is 1. This is 1. Times cosine x leaves you cosine x. A cosine of pi over 2 is always 0, so that dies. Sine of pi over 2 is 1 here, times cosine x is cosine x, and cosine pi over 2 here dies. Cosine x equals your cosine x. They're identical. Okay. Number 9, secant of an arc sine is 12 over 13. And so again, you label it like it's a sine, which means 12 over 13, and 169 minus 144 is 25. Take the square root of 25 and get 5. Secant is the inverse of cosine, which means cosine would be 5 over 13, secant would be 13 over 5. I'm going to solve this for x on 0 to 2 pi. So cosecant squared is 4. Flip it, you get sine squared is 1/4. Sine is plus or minus 1/2. If sine x a half, you're at pi over 6 and 5 pi over 6. If you're at negative a half, you're pi over 6 into the third and fourth quadrants, which means 7 pi over 6 and 11 pi over 6. I'm not adding the plus 2 pi k because we took that stipulation on it once around the circle. Okay, well, you can use a calculator on a lot of these problems. Your cosine x, you add the 0.4 over, you get positive 0.4, and divided by that 2, you get 0.2. Punch an arc cosine on that, and you get 1.369, which is your reference into the first. That'll be your reference down here. So the other angle comes from 2 pi minus that, and get 4.914. You sketch a graph of this, you'll enter this is equal to 1 sine of 3x. Your period is 2 pi over that k. What's the k value, if you remember? It's fading. So that's 2 pi over 3. And if you graph y equals sine of 3x, you'll get the sine graph in the middle, and if you remember, every x-intercept is a vertical asymptote, and the humps between them flip up and down to u's. You can just punch this straight in on the calculator, and remember, they also call that a k, but on a tangent and cotangent, a period is just pi over that k. All right, for a formula like this, your amplitude is the front coefficient, absolute value of it, just the number. Remember, it's never negative. Period is 2 pi over that k. Vertical shift is the number added on. And here's where I'm showing the phase shift or horizontal shift. You factor out the 3, leaving you x minus n of 1/3, and this is horizontal shift. And it's positive if the formula has a negative, because you're shifting right. (15) is a law of sines problem. We've given these two, well, I've given all three angles. So a sine of 100 degrees is, or x over the sine of 100 is equal to 2 over the sine of 50, and you'll multiply both sides by the sine of 100. Make sure you're in degree mode. Punch away, and it'll wind up being 2.57. 16 is a classic side angle side problem. Remember, it's a simple modification. It looks like a Pythagorean theorem, but it's not a right triangle, so it gets modified by this extra term. So you start with the side you don't know. It's equal to the other side, one side squared, add the other side squared, subtract twice, times the product of those two sides, cosine of the angle opposite, whatever that side is. Make sure you're in degree mode so that this comes out proper. Out to this, take a square root, get this. I really, remember you can report answers to the precision of the problem, so I really could have written this as x just equal to 574. But we'll take either answer, not that picky. 17 is an arc length problem. If you remember, an arc around a circle is the product of the radius times the angle in radians. And given that 45, so starting from the x-axis, if that's 45 plus 90, you got to be at 135 degrees. You can go ahead and convert that to radians of kind of all in one step. I'm multiplying by pi over 180. And interestingly enough, you don't have to be in degree mode to punch this out. It's just arithmetic. You're not taking a sine, a cosine, a tangent value of it. It's just numbers. You get the same answer on this if you're in degree mode or radian mode. All right. I think the last three problems we reach back to chapter 4, logs and exponentials. So if we're going to solve for x, we can combine those, and since they're both positive, they'll just be a log of a product. And then we want to get rid of that log, so we get 10 to that power, 10 to that power. And that gives us x minus 3 equals 10. Distribute here and subtract the 10. And then it factors, and you'll have x equals 5 and negative 2 from this, but then you got to watch. But a negative 2 makes that log negative and that log negative, and it's not valid. Not legal, we'll say. It only has to make one negative to be not legal, so it doesn't really matter that it works in both. If it makes even one of them legal, it's illegal, not in the domain. All answers have to be in the domain, and domain of logs is positive k to 0. All right, number 19 is about solving for x in exponentials. E to the 2x plus 1 there, and to undo e, we have a natural log. And so that leaves you these cancel, leaves you 2x plus 1 is natural log of 200, which punches out to this. Subtract 1, you can see you get to 4.29a divided by 2, and you'll wind up at 2.149. You don't have to worry about illegal answers with this because domain of E or exponentials is all real numbers. All right, and number 20, give you a formula for bacteria colonies, kind of a word problem. When A is 50,000, find your T. So we're going to unravel this and solve for the T. Divide by the 10,000, divide by the 10,000, I'll leave the E by itself. Undo E, you need natural log. That gives you the natural log of 5. And over here, it undoes the E, leaving the 2.1 T. Divide by the 2.1, and it should point out or punch out to 0.7664. And you don't have to worry about illegal numbers. All right, I hope that helps. That's a very quickie review. It's the last Zoom meeting of the semester. Feel free to email me with any questions. Final exam will be available Tuesday. Let's see, it should all right, test 4, Sunday, due Sunday. It's over 7.1, 2, 3, 4, 5. And final exam. Available on Tuesday. And due Friday. And that is the absolute Friday. 5/7 is the absolute deadline. To turn any course materials. All righty. enjoyed this semester, enjoyed working with you. We will answer any questions that you might come up with. But otherwise, I guess we should have mentioned that the WebAssign over 7.5 also due Sunday 5/2, but Sunday 5/2. But again, you know, if you need till Friday 5/7, 5 p.m., you know, that's fine. We'll give out a grade report if you turn this in by Sunday. Give out grade report. If I had your test by Sunday, otherwise I'll just assume you're going to turn it in by Friday, and I won't send you a report with a 0 on it. Don't want to freak anybody out. All right. Good luck.